Let's take a look at this idea of parametric coordinates. Now, parametric, it's just a different way of describing graphs. Now, we're used to describing it, y equals x squared and things like that. So in Cartesian form, when we write it like that, we describe our curve with one equation, and the points are described by two numbers, an x value and a y value. Parametrics flips that idea on its head. So in parametric form, the curve is described by two equations. One equation for the x value, one equation for the y value. And the points are described by one number. And then you substitute that number into the two equations and you come up with the coordinates of the point. And that number is what we call the parameter. And those who are great in English and linguistics and things like that, which I know you all are, the word itself suggests that. Parametric, pair of measures. Here's y equals x squared, our parabola. Of course, that's the Cartesian form, y equals x squared. There's more than one way of writing it, of course. It just means the parameter would change. I've chosen to do it this way. X is t on 2, y will be t squared on 4. They would be my parametric equations. So over here we've got the point minus 1, 1. That would be the Cartesian coordinates of that point. Well, the parameter of that point is simply t equals negative 2. If you were to substitute negative 2 into my x and y equations, you would come up with minus 1, 1. Okay, minus a half a quarter would have parameter t equals minus 1. The origin, that's t equals 0. A half a quarter would be t equals positive 1. And 1, 1 is t equals 2. So how do we convert between the two forms? How do I change from the parametric form and come up with the Cartesian equation? And basically you eliminate the parameter. It's like having simultaneous equations, but you eliminate the parameter. So here's my parametric form. X equals 2t plus 1, y is 3t minus 2. Show that this indeed would be a straight line. So I'll make t the subject of one of them. It doesn't really matter which one. I've chosen the x equation. So t is a half x minus 1, substituted into the y equation, tidy it up, there's the equation of a line, the Cartesian equation. Y equals 3 on 2x minus 7 on 2. So basically eliminate the parameter. Sometimes it's not as immediately obvious how to eliminate the parameter. The parameter here is theta, it's the actual angle. Now, how do we make theta the subject in one and substitute it into the other? Well, when we're dealing with trig, I don't have to. I'm going to use the identity sine squared plus cos squared equals 1. So rather than making theta the subject, in the first one I'm going to make cos theta the subject, and in the second one I'm going to make sine theta the subject, and then substitute into the identity that I know is always true. Sine squared plus cos squared is 1, always true. Sub that in, we come up with a Cartesian equation, and we can see straight away, I don't have to expand it out, there it is, it's a circle. X minus 2 squared plus y minus 1 squared is equal to 1. Let's have some fun with these. We're going to complete a table of value for this one. X is sine theta and y is sine 2 theta. We're going to use all these different values for theta. They're going to be our parameters, and see what this curve looks like, because you can actually get some quite interesting curves putting it in parametric form. There's the table of values. I've already worked it out for you to save you some time. Let's now plot it. Oh, there's one point. Oh, there's the next. Oh, look. Okay, it's starting to form. All those different points are now being plotted. What on earth does this curve look like? Well, it actually ends up looking like that. Isn't that an interesting graph? Oh yeah, I mean obviously if you just chose those points, it's very hard to work out what the curve is. And so like any sort of curve sketching, if you're unsure, plot more points until the picture starts emerging and you can see what it is. Now, Cartesian equation. I need to use this identity. Sine 2 theta actually turns out to be 2 sine theta cos theta. We'll come across that later. So using a bit of Pythagoras here, if sine theta is x over 1, the adjacent side becomes the square root of 1 minus x squared, I can now substitute into y, and there's the equation of our curve. Y equals 2x square root of 1 minus x squared. Well, actually, no, that's not the equation of the curve. That is. Y squared is equal to 4x squared, 1 minus x squared, would get the complete picture. What would the second last line give me? Ooh, careful. No, it won't. It'll give you the first quadrant and the third quadrant. Because notice, y is equal to 2x times 1. So when x is negative, y will end up being negative. So you actually end up with the first and the third quadrant on that one. Okay. Well, yeah. Fancy. There we go.